That's all right.
Is there one for each of them? Or like,
Yeah, there's one for each.
There's 6 options and there's 6 guesses.
Well, I didn't know that. I didn't know
All right, so as you guys are still trying to do that, here's what we're trying to learn here in this section. All right, our target is to graph and describe transformations of functions. So those are 6 different functions, and we're going to talk about what a transformation is, and then to know if you're successful or not. Those are the 3 things you should be able to say. I can identify the function family to which a function belongs. I can graph transformations of functions. I can explain how translations, reflections, stretches, and shrinks affect graphs of functions. So that's where we're headed today and on Monday. All right? So here's the exploration you're working on. Okay? This first one, what do you guys think it is? No. At least you're guessing, that's all right. Nope. Hey, come on now. Let's look at number 5. Look at 5. We should know that one. That's the quadratic, right? We just had a quiz on it, right? We should get that one.
Well, technically it's a parabola.
Yeah, but it's a quadratic family type. Okay, so we call these parent functions, okay? Or the family of functions they belong to, all right? So quadratic we got. That's the one we should have known for sure because we just had a quiz on it, right? And they are called parabolas, the graph of a quadratic, okay? Which one do you think is constant? Think of what constant means. The same. 3, Andrew? 4. Yeah, 3.
Yes. You got that.
Okay? This is the constant one. No change. It just stays the same. So you see a horizontal line. That's part of the constant family. That's the parent function for the constant family. All right. So the next one that's really easy should be linear. Which one's that? Yeah, the last one, the bottom right there, the number 6. Again, the word line is in linear, right? See that? So that's a line, a picture of a line. All right? But that's the parent function. That's the basic one we look at when we talk about a linear function. The one that goes through the what? What's the y-intercept? The origin, right? 0, 0. What's the slope? 1 over 1. Good. All right. So, absolute value. Which one do you think that is?
Ivy.
No, not 4.
Oh.
Look at this. Word.
Oh, V.
Number 1. Yeah, the one that looks like a V is the absolute value. It's the V. Easy, right? Okay? And those are the 4 main ones we're going to talk about. But just to let you know what these are, this one is the square root. And you might remember some of this. You probably didn't see the square root one in Algebra 1. You probably saw the exponential one. Exponent, I-A-L, right? Okay. And like if we think about square root, what's the square root of 0? 0. What's the square root of 1? What's the square root of 4? 2, right? So there's 3 of those points right there. Okay? So again, the four main ones we're gonna talk about in this section are 1, 5, 3, and 6. They're those ones on the corners. All right, so just to give you, start thinking about stuff. Again, parent function or family that a function belongs to. All right, so functions that belong to the same family share key characteristics. The parent function is the most basic function in a family. Functions in the same family are transformations of their parent function. We're going to talk about transformations in a minute. Okay, so the four types that we're going to talk about were those ones on the four corners. Okay, so you might want to, write all this out or keep it for reference to do your homework tonight, because you're going to be asked what family does this function that they give you belong to, and they're going to want you to graph that function and the parent function that it belongs to. Okay? And then we're going to talk about domain and range. And you guys already know domain is which values? The x values. And the range is the y value. So we already know that, right? We've been working on that stuff. Okay, so our four families are constant, linear, absolute value, and quadratic. Those are the four main ones we're talking about. Okay? And they all have a rule. They all have a function, that the basic function they use for each family, each parent. F of x equals 1. F of x equals x. F of x equals, those two symbols around it mean absolute value of x. You guys have seen those before, right? And then quadratic, we know, is got an x what? What did all of our problems that we just got done doing have with that first x? We always saw an x to the second, right? An x squared. So those are the four families we're going to really concentrate on. And those are the rules or the function that goes with them. All right, and then the picture or graph. So when you have a problem and it says, which family or parent function goes with this function, and you pick linear, let's say, then you're going to draw this picture for linear. Okay, that one. For constant, you're going to draw this picture for the parent. Always a horizontal line through the number what? What number is this going through here? 1, right? Because that's what it says. And remember, you're used to seeing, this is in function notation, but you're used to seeing y equals 1 and y equals x. They're the same thing. And y equals the absolute value of x. And y equals x squared. We like the y equals because we can use our calculator. We have a y equals button, right? To graph. So if you have your graphing calculators with you, get those out because we're going to use them in a few minutes. Okay? So the absolute value, what's that look like again? Value looks like a V. Good. Oops, I got to go back to my pointer. Okay? And we all know that the quadratic is called a what? Parabola. And so whenever you have to draw or graph the parent function for each family, that's what your parent function will look like for each one. Okay? And what would be the slope of this horizontal line? 0. Good. Whoa. I got to go back to my pen now. Sorry. And what's the slope of this one?
1, 1.
1, right? Whatever's in front of the x. Remember y equals mx plus b stuff, right? What's the slope of this side? The right side?
1, 1.
That's also 1. What do you guys think the slope is of the left side? -1. Very good. And we don't have a slope on a parabola, right? We have that curved graph. But we have y-intercepts on all of those, don't we? So you should know what the y-intercept. These three are all the same y-intercept. All at the origin at 0, 0 for our parent function, what it looks like. All right, let's think of domain, x values. Can the x values be anything on this line? On the constant line. These arrows tell me what about that? They go on forever, right? X values are this axis, right? So can they be anything? Yeah, so what's our domain? All real numbers. What about the linear one? What do you think? This keeps going, so can I go this way forever? Yeah, so that's also what? All real numbers. What about these? Will these just keep going? Yeah? So what do you think? All real numbers. And we already know this one, we just had a quiz over this stuff. What's the domain of these parabolas? All real numbers. That means x could be any number, right? Any positive or negative, fraction or decimal. Okay? Now the ranges are a little different. Okay, ranges are the y values. So what about this first one, this constant one? Yeah, it's equal to 1. That's always 1 in this one, right? So y equals 1 is the range of that one. What about the linear one? Can a line keep going in all directions this way? Yeah, so what could we say for that range?
All real numbers.
That's all real numbers, right? And remember, our little symbol for all real numbers is the parallel lines and then the R in there, right? What do you think about the absolute value one? Can all the y values work, or are there some y values that aren't working? Look at the picture. Right here, the y value was always just 1, right? Here it went in both directions forever. You know, this way or this way, right? What about this one? Third?
Can it like technically be any number since absolute value you have the two things that always makes it a positive?
Well, but for this picture, yeah. Depending where your graph is drawn, yeah, it could be anything, but according to this picture, we don't have every y value possible. We could think of, you know, what do we call this if it had opened up with this point? Was that a what or what?
Min.
Min or max, right? Basically, we got a min on here too, right? What's the minimum y value?
Yeah.
0. So what's our range going to be?
Y is greater than or equal to.
Right, this one's going to be y is greater than or equal to 0. What about the quadratic picture?
Y is greater than or equal to 0.
Yeah, same thing, right? Those two are the same. Because according to those two pictures, there's no y values that are below 0, right? You understand what I'm saying? There's no points on the graph that are below the x-axis. So that's why my y values are all 0 or bigger. Make sense? Any questions so far? Okay, so those are our 4 main parent functions. And again, when you're asked to graph the parent function that goes with a certain problem, if it's a constant problem, that's the one you're going to draw. If it's a linear problem, this is the one. Absolute value, that one, quadratic that. Okay? Remember, anytime you want to figure out a graph, and let's say you don't have your graphing calculator, what was the first thing you learned when you were taught how to graph? What do we call this?
Table.
An XY table, right? And what did we always use for the domain, the X value? Right. Isn't that how you started when you first were introduced to graphing lines? You guys remember that? Way back in the 70s when I was a freshman in high school. That's how they taught me too, the XY table. All right? So again, since my domain is all real numbers, I can pick any real number for X. These are usually the ones we always pick because it's easy to add, subtract, multiply, and divide by those 5 numbers, isn't it? We don't get real big numbers for answers usually. So that's why we use it. But you can pick any numbers you want. All right, so which family does this belong to? Absolute value, the V, right? Okay? It says compare the graph of F. So here's F, they called it. Sometimes they call them G's, sometimes H, but most of the time it's F. And it's in function notation. And the graph of its parent function. So the parent function, remember, has a 0, 0. Let's do a different color here. And what was the slope both ways? Remember? No. 1 and -1, wasn't it? 1 is up 1 over 1. -1 is up 1 and left 1. So let's compare the red to the blue. Okay, so we always start out at the parent. What did this blue one do first? Jumped up? How far? 1, right? So we're comparing them. So it went up 1. What else does it look like happened? It got a little thinner or skinnier or narrower, right? So what changed on the blue lines? What changed? Well, the slope, yeah. Got narrower. Slope changed, right? Okay. So we just kind of compared it and just talked about what happened. Okay. I think that's the only one on this slide. Any questions? So again, it was a V, so it was an absolute value type problem. So that's the family it belonged to. And then you were supposed to graph the parent function. So we always use that for the absolute value family. And then we just compare them. See what happens. Okay? So, get out your calculators. I want to show you how to draw an absolute value graph on your calculator. All right? So, again, how do we always get to the graph part on our calculator?
Y equals
Yeah, that's our y equals button, right? That's why we like to solve for y everything. All right? So to get the absolute value symbols to come up, hit this math button. It's third one down, far left. And then hit the right arrow key to highlight NUM for number. That first thing says ABS. That's standing for absolute value. Okay? So you're going to just hit enter. And then the X is right next to alpha, between the stat button and the alpha button. Okay? and then close it up. I have to use parentheses. Some of you have a newer version, it'll actually have the straight lines for you, okay? So if I hit graph, there's my V, my parent function. All right? If we put this one in, the 2 times the absolute value of x plus 1, go back to your y equals, hit enter, put your 2 in, and then how do I get absolute value again? What's first? Math, right arrow key for number, the first one. So 2 times the absolute value of x, close it up, plus 1. Hit enter, and then hit graph, and you'll see both of them. There's the second one. So you can use your calculator to help you look at these graphs. Questions? If you don't have one yet, you need to get one. All right? If not, you got to do your own XY table and fill everything in. Alexa, did you have your hand up?
Maybe not. I
Sure.
think it would do the second one.
You wouldn't do it?
Yeah.
Mine, Mr. Mattingly, mine like takes upside down.
So then you must have put a negative somewhere where you shouldn't. Yes,
Mine just says error.
that is fine. All right, hit second. If you're getting errors, hit second y equals, and everything should be off. Is anything on? Say on there. Nothing says on.
Yeah, mine did.
All right. So hit number 4. Says plots off, then hit enter. So it says done, and then hit graph again. It should show up then. Not working for you? All right, we'll get it fixed.
Yeah, mine will do the second one still.
All right. Sometimes, see how these equal signs are highlighted black? You got to make sure they're highlighted black for it to show up too. Sometimes they don't for some reason. And I'm not sure why that happens. Joe, you with us?
Yep.
You sure?
Yep.
Okay. Josh? Didn't work? All right, we'll get there. All right, a transformation changes the size, shape, position, or orientation of a graph. All right, so that's what we're looking at, transformations. It just changes the look of it a little bit. A translation is a type of transformation that shifts the graph horizontally or vertically, but does not change its size, shape, or orientation. So it only moves it up or down or right and left on a translation. You guys have these, I think, in Algebra 1. So what parent function does this go to with? What do we call this family? Quadratic. When you see an x squared, it's a quadratic family. Parabola family, right? So what do you think is going to happen there? If it's a translation we're talking about, is it going to move it up, down, right, or left, forward? Okay? Up, forward. It's a good guess. Let's see if he's right. So, go back to your calculator, hit clear, enter, clear, so that you can start over. What's my parent function? X squared, right? So hit X, remember, right next to alpha. Squared button's over here. Couple down from math, below it. Hit enter. All right? And then the other one was x squared plus 4, right? So I want to put that in the other one. So x squared plus 4. And then I'm going to hit graph. Here's my parent function. And there's the other one. It moved, like Nathan said, up 4 units. Okay, so what's not happening is yours
It's
not.
just not working.
See how the first one's got highlighted, the equal, that's not highlighted. So if you hit that, go down, now they're both highlighted. It should both work. Only one function and up to 3 plots will graph. Okay, so let's try something. So it gave the red one, and then it won't do them both at the same time. I'll have to figure out why.
Okay.
Well, Google it or something. Carden,
Mine like works like it grabs it, but then like it only shows for 1 second and it says error.
okay. Something wrong with your window, probably. We'll get it fixed. As you can see on mine, why doesn't it show what it's supposed to show there? This is not doing what it should be, but it'll show my, it'll show what my things are, but I don't know why it didn't change with that one, because it changed. Usually it'll tell me my table, and it'll show me a picture of the graph. I don't know why it didn't work. Okay, so there is a picture of those two graphs. So what we're going to do is describe it. What do you think will happen? We're just going to say up 4. So what do you think, if that's up 4 with the plus, what do you think is going to happen with the minus? It's going to go down 3. Make sense? That is correct. It'll go down 3. Let's look at another one. What do you think is going to happen here? Look at the difference between the first one. X squared plus 4, and now we got x plus 4 in parentheses squared. You ready?
I think it might go right 4 and then up 4 maybe.
Okay.
Or
Let's
right
think.
2 up.
Let's look and see what happens. So this second one, we're going to put it in parentheses, x plus 4, and then square it. So when it's inside the parentheses or inside the absolute value signs, and then we graph it. There's our parent function, and there's the other one. What did it do? What happened? When it was outside the parentheses, it went up 4, or outside parentheses down 3. When it's inside the parentheses, what happened?
Yeah, it shifted left.
It shifted left. Okay? What value for x do I need? Oops. What value for x do I need to put in here to make that equal 0?
Negative 4.
-4. So it actually is going the opposite direction of what you think. Because you want that to equal 0 to find that y-intercept or x-intercept, depending on what we're looking for. Okay? So this one is left 4. So what do you think is going to happen here?
Right.
It's going to go right 3. So there's our translations. Okay? So inside the parentheses, they change that. We go opposite of what we think. If it's outside the parentheses, it goes exactly what we think. Up or down. Okay? On the translations. Questions? Ty, you okay? Okay. All right. What parent function is this? It's this x minus 6. No absolute value signs. No squared symbol. No single number. Nate? Yeah, this is linear. When you just have an X and any numbers with it, that's the linear family. Okay? So what's the parent function look like? It always goes through the origin, right? And what did we say the slope was? 1, right? So it's going right up there. That's at y equals x line. X and y are the same. 1, 1, 2, 2, 3, 3, negative 1, negative 1, negative 5, all that stuff. They're all the same. All right, so here's our parent function. So since this is not in parentheses or anything, what do you think's happening with this? No parentheses. Down 6, yeah. And you guys already know how to graph that. What's the slope? 1. What's the y-intercept? Negative 6. So there's our y-intercept, and slope is 1. There's our line, which has moved down 6. That's our translation. That's a type of transformation, right, Angela? Okay? I probably got a B. All right, here's absolute. What family is it?
Absolute value.
Absolute value family, right? All right, so let's draw the parent function. We should be getting good at this. 0, 0, and then going up 1 to the right and negative 1 to the left. So that's the parent function. Again, if your graphing calculator's not working, or you don't have one, I guess, you got to make an XY table for this stuff. All right? Now you're going to have to do this. And plug in numbers. And see what happens. Okay? What I'm going to do is use my calculator. Put in my y equals, clear it. And this is absolute value. How do I get there again? Math. To the right one for number. Enter, right? We just put an X there. And then this one is X minus 2, wasn't it? So we go math. It's inside too, right? Math. Number. Enter. X minus 2. So it's inside the parentheses or inside the absolute value symbol. So which way do you think it's going to go? Liz? Right to. Let's see if she's correct. Here's the parent. Oh, I put, what is going on?
I think you had a square.
Did I have it? Oh, I did. Forgot to get rid of it. Thanks, Haley. Because if I get a square, then it's a parabola, right? Sorry about that. So there it is. It moved it right to, like Liz said, because it was inside the absolute value set. And again, I don't know why this right side is not working. It should show me my two equations, my 2 tables, and then my 2 graphs.
Mr. Manuel.
Yes.
When I click the right arrow on the like the bottom, it says like x equals, and then on the other side of the graph it says y equals 0, and then if I keep like going right, number on the x keeps going up.
On your calculator?
Yeah, like on
Okay.
the lower left.
Okay. I'll have to look at yours too. I need to look at Isabella's and yours. Who else do I need to look at?
I actually have a question. How do you put X?
X is this one. Like this. All right. Okay, so we getting the hang of this a little bit? Translations, reflection, another type of transformation. All right, it flips the graph over a line called the line of reflection. A reflected point is the same distance from the line of reflection as the original point. but on opposite side of the line. It's like our axis of symmetry, right? Okay? Like we did when we graphed, right? We went on the same distance from either side of the axis of symmetry, right? It was like a reflection there. All right, so here is the graph of y equals x, and then the graph of y equals negative x, absolute value of x. It reflected it how? The blue one's the parent, the red one, what they do?
They put a negative.
Right, with the negative reflected how? Which axis?
The X.
Yeah, about the x.
Will it ever go above the Y?
Yeah, we'll do that too. We can do both.
Can you change it from like an X to a Y on your calculator?
No, you can't. What happened here? What do you think?
The number gets switched to a positive.
You know, if we do this, what's going to happen when I put negative of a negative 2 in there? What's the absolute value of it? Positive 2. What's going to happen here? Positive 1, 0, 1. Is it going to change at all? No, not with those absolute values. It didn't reflect at all, right? Or it reflected about, I guess it went about the y maybe, because it's, you know, if it reflected about the y, it still looks exactly the same, right? Okay, so reflections and translations. Use your graphing calculator to help you. All right, there's a couple examples that I didn't get to. There's your assignment.
Is it on the Canvas page?
Yeah,
Alright,
this is all on Canvas, or will be.